Hello, welcome everybody. This is MISIAN Online Mathematics again, and today we are going to look at a chemistry question. The question here on the whiteboard, it says 30 centimeter cubic of aqueous sodium hydroxide contains 8 grams per liter of sodium hydroxide who are completely neutralized by 0.294 grams of diabatic acid. The question now is asking us to determine the RFM of the diabatic acid given that sodium is 23, oxygen is 16, and hydrogen is 1. So the first thing you do with this kind of question, you write a well-balanced chemical question so that you can use the mole ratio to help you determine the RFM of the diabatic acid. So let's try to write the chemical question and balance it so that we can continue from there. If we have sodium hydroxide, when you react sodium hydroxide, what you need to remember here, sodium hydroxide is neutralized. This forms a salt plus water. So this is sodium hydroxide. We are reacting with an acid. Sodium hydroxide plus acid will give you a salt of sodium X plus water. So water is in liquid form. This is in aqueous, and also this is in aqueous. Also this. Let's balance the question. We have sodium 2, sodium here 1. We can put 2 here, and now we have oxygen is 2. Oxygen is 1, hydrogen is 4, here is 2, we can put 2 here, so we have 4 hydrogen. The question is balanced. And then the next thing we do here, we are going to determine the mass of sodium hydroxide used here. If we are given that sodium hydroxide contains 8 grams per liter. So we can say if 8 grams is contained in 1,000 centimeter cubic, what about the 30 centimeter cubic we are given here? Will give us what? How many grams? Which is now, this is the same as 8 times 30 over 1,000, and this will give us 0.24 grams of sodium hydroxide. Now the next thing we need to know is now the number of moles of sodium hydroxide. So if we want to know the number of moles of sodium hydroxide, number of moles of sodium hydroxide, we know that number of moles will be mass over RFM, and the RFM of sodium hydroxide given the mass which we have here already, 0.24 grams, divided by what is the RFM of sodium hydroxide. Sodium is 23, oxygen is 16, 23 plus 16 plus hydrogen 1, you will get is 40. Then if you divide this, you will get 0.0 0.06 moles. Now, from here, we will use our equation here to determine the number of moles reacted here of the diabetic acid. We know that here the mole ratio is 2 to 1 to 2. But we are interested in the diabetic acid here. So this is the number of moles which were reacted for sodium hydroxide. Using the mole ratio here, to get the moles of the diabetic acid here, we divide by 2. We take this, divide by 2, then it will give us the number of moles for the diabetic acid, which will be 0.003 moles. Now, for us to find now the last part, the RFM of the diabetic acid, RFM of the diabetic acid will be given by number of moles, will be given by mass divided by number of moles, which will be equals to mass we are given, which was used to neutralize completely, is 0.294 grams, divided by what's the number of moles we got here of the diabetic acid is 0.003. If we divide this, we'll get 98 grams. So the mass or the RFM of the diabetic acid is 98 grams as the question wanted. This is the answer. So please feel free to share this video and give a thumbs up, and see you next time.